Watch this video in Lesson Reach. Pause and ask questions, take a quiz, or get help with assignments. Link below.
Welcome to this custom deep dive. You know, whenever Neelkantha Bhanu Prakash breaks, like another world record for mental math, my immediate instinct is just to assume he was born with a silicon chip in his head.
Oh, yeah, like a literal human calculator, right? But when you look at section 3.6 of chapter 3 from Contemporary Mathematics, it becomes pretty clear that it's actually not about raw processing power.
Right.
It's really about exploiting the architecture of numbers.
Which is exactly why I'm taking the front row today. I'm going to act as your eager student, and you get to be the lecturer to guide us through all this.
Oh.
I really want to uncover the secrets here. So walk me through this architecture. Are these just hacks or what?
Well, Professor Mode activated, I guess. So yeah, let's start with the basics. First, we need to define what actually makes a number real.
Okay, wait. If there are real numbers, does that mean there are, like, fake ones out there?
That is actually a great question. So real numbers basically combine rational and irrational numbers to represent all physical distances. That includes 0 and, their negatives.
Okay, so like a tangible thing.
Exactly. The textbook gives examples like dividing a space into 3/8 or using the square root of 10 to represent the hypotenuse of a right triangle. That's a real physical length you can measure.
Even if it's some messy, infinite decimal, it still maps to reality.
Yeah, precisely. But to your question about fake numbers, if you try to take the square root of a negative number, say the square root of -1, there's no physical shape you can draw to represent that distance.
Ah, right. It's just physically impossible.
Right. So anything with a negative under a square root is what we call a complex number, denoted by the letter I. It's not real because it can't represent a physical length.
Okay, I'm tracking with you. So as long as we stay out of that complex territory, we have this massive collection of real numbers. But how do we organize all these, physical distances?
Well, we use subsets. The textbook breaks them down into natural, which are your counting numbers, then whole numbers, which just adds 0, then integers, which includes negatives, then rational numbers like fractions, and finally irrational numbers.
That's a lot of categories. But for you listening, I like to think of it kind of like a Venn diagram, or actually Russian nesting doll.
Right, yeah, that's a good way to look at it.
Right. You always categorize a number by the smallest, tightest doll it fits into. So for instance, -7 is real, and it's rational, but its most specific label, its smallest doll, is an integer.
Exactly. Spot on. And knowing which nesting doll a number belongs to is essentially the secret to doing rapid mental math.
Really? How does knowing it's an integer actually speed up my brain power, though?
Because real numbers follow very predictable structural rules. Things like the commutative property, where you can move numbers around, the associative property for grouping them, plus the distributive, identity, and inverse properties.
Okay, lecturer, you're losing me a bit with the vocab. Give me a concrete example.
Fair enough. Try this one from section 3.6. Multiply 4 by 13 by 25 in your head.
Okay, doing this the hard way, left to right. 4 times 13 is, wait, that's 52. Now I have to multiply 52 by 25, and I'm instantly reaching for my phone.
Right, but you don't actually need to read left to right. If you apply that associative property we just mentioned, you realize the grouping doesn't matter at all.
Oh, I see where you're going with this.
Yeah, you can completely bypass that ugly 52.
But pairing the 4 and the 25 first, because 4 quarters make $1, so that gives you a clean 100?
Exactly. And suddenly, multiplying 100 by that middle number, the 13, takes 0 effort. You instantly know the answer is 1300.
Wow. Okay, yeah, that is so much easier.
Yeah, this is exactly what mental math athletes are doing. They aren't brute forcing calculations, they're just using the associative property to find the path of least resistance.
So the main takeaway for you listening is that mental math isn't just about intense memorization. It's about leveraging those structural rules of real numbers to your advantage. It's like a game.
It really is, and once you see the matrix, you kind of can't unsee it.
Definitely. And to see this pushed to its absolute limit, the textbook recommends checking out a TED Talk by Arthur Benjamin called Faster Than a Calculator. Highly recommend you go watch that to see another mathematician just completely dominating these concepts live.
Oh, it is mind-blowing. He's incredibly fast.
Truly. So as we wrap up this deep dive, I want to leave you with a thought to mull over. Watching these people work, you have to ask yourself, is math just some practical tool we invented to count physical objects? Or is it actually a hidden underlying language of the universe that these human calculators are just, fluent in reading?